Hello everyone, I am Nikita Nayak from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Today we are going to learn about set theory. So first of all, introduction. One of the widely used concepts in present-day mathematics is the concept of sets. It is considered the language of modern mathematics. The whole structure of pure or abstract mathematics is based on the concept of sets. German mathematician Georg Cantor 1845 to 1918 developed the theory of sets, and subsequently many branches of modern mathematics have been developed based on this theory, that means set theory. In this unit, preliminary concepts of sets, set operations and some ideas on its practical utility will be introduced. So, first of all, sets and their representation. So, what is the set? Set is a collection of well-defined objects. Well-defined means it is mean that given a particular collection of objects as a set and a particular object, it must be possible to determine whether that particular object is a member of the set or not. The objects forming a set may be of any sort. They may or may not have any common property. Let us consider the following collections. Number 1. The collection of the prime numbers less than 50. So, what is the prime number? Prime numbers are the positive integer having only two factors, 1 and integer itself. That means 6 has factors 1, 2, 3 and 6. That means 6 is not a prime number. Elsewhere, 7 has factors 1 and 7. That means 7 is a prime number. So, prime numbers less than 50 are 2 because 2 has factors 1 and itself 2, 3, 5, 7, 11 and 13. Now, collection 2. The collection of 0, A, Sachin Tendulkar and the river Brahmaputra. Number 3. The collection of the beautiful cities of India. There are so many beautiful cities in India. Number 4. The collection of great mathematicians. Clearly, the objects in the collections 1 and 2 are well defined because, for example, 7 is a member of 1. Why? Because 7 is a prime number as it has two factors 1 and 7 itself, as well as 7 is less than 15. So, 7 is a member of 1. But 20 is not a member of collection 1 because 20 is not a prime number as well as 20 is greater than 15. Similarly, A is a member of collection 2, but MS Dhoni is not a member because in collection 2 we have given particularly 0, A, Sachin Tendulkar and the river Brahmaputra. So, as the collection 1 and 2 are well defined, the collections 1 and 2 are sets. But the collections 3 and 4 are not sets since the objects in these collections are not well defined because in collection 3 we have given the collection of the beautiful cities of India. And as we know, there are many beautiful cities in India. And number 4, the collection of great mathematicians. And we know that there are so many great mathematicians in the world. Now, what is the member or element of a set? Any object belonging to a set is called a member or an element of that set. Other definition, the objects forming a set are called elements or members of the set. Sets are usually denoted by capital letters. That means denoted by capital A, capital B, up to capital X, capital Y, capital Z, etc. And the elements of these sets are denoted by small letters. That means denoted by small a, small b, small c, up to small x, small y, small z, etc. If A is an element of a set A, then we write A belong to A, which is read as A belongs to the set A. Or in short, A belongs to A, or A is an element of the set A. And if A is not an element of set A, then we write A does not belong to A, which is read as A does not belong to A, or A is not the element of A. For example, let capital A be the set of prime numbers less than 50. And we know prime numbers, that means positive integers having two factors, 1 and integer itself. So, prime number less than 50 are 2, 3, 5, 7, 11 and 13. So, A is equal to set of 2, 3, 5, 7, 11, 13. Therefore, 2 belong to A. That means 2 is a member of A. 3 belong to A. 5 is an element of A. 7 is an element of A. 11 belong to A. And 13 belongs to A. But 1 does not belong to A. 4 doesn't belong to A. 10 does not belong to A. And we know that elements of sets are always denoted in curly bracket. Note, we encounter many words which convey the same idea as that of a set. We shall use the words class, aggregate, collection as synonyms of the word set, particularly to avoid using the same word repeatedly in a given sentence. Now, representation of sets. There are two methods for representation of sets. First, listing method or tabular form. In listing method, all the elements of a set are listed. The elements are being separated by commas and are enclosed within braces, that is curly bracket. For example, the set of all natural numbers less than 6 is described in listing method as set 1, 2, 3, 4, 5. Method second, property method or set builder form. In property method, all the elements of a set possesses a single common property which is not possess any element outside the set. For example, the set of all natural numbers between 4 and 9 described in property method as in curly bracket x, where x is a natural number and 4 less than x less than 9. Remark: no restriction has been placed on the objects that can be members of a set. It is not unusual to have sets whose members are themselves sets, such as S is equal to in curly bracket A, comma set 1 comma 2 comma P comma set Q curly bracket over. However, it is important to distinguish between the set Q, which is an element of S. Here, set Q is element of S, and the element Q, which is a member of or element of set Q, but is not a member of S. That means set Q is a member of S, Q is a member of set Q, but this Q is not a member of S. In next video lecture, we will learn about inclusion and equality of sets. Thank you.